Welcome back. My name is Atif, and you are watching Base2's FastAPI-AsyncIO Foundation Course. This is the second module of this course, and we will learn about sequential and concurrent execution of async tasks. Take a look at this use case. We have a set of tasks. We need to retrieve product data from an API, then we have to validate it, and finally, we need to save data into database. It's not possible to validate data before retrieving it from the API, and we cannot save data before validating it. So these tasks follow a sequential order. They are naturally sequential. We cannot perform them concurrently. Let's see how to implement such tasks with async IO. We have defined coroutines for each of the tasks I just described. First, we have get data coroutine, which takes the API URL as the parameter, and it returns dummy response data from the API. We are still simulating the operations with asyncio.sleep. We are doing so because we want to stay focused on the main topic of this module, which is sequential and concurrent execution of asynchronous tasks. In module 4, we will take a look at some use cases and we'll implement them actually. For example, calling the APIs and saving data into files. But for now, we will keep simulating with sleep. Second function or coroutine we have is validate, which takes the API data and returns the validated data. And third one is save in DB, which takes the validated data as input, and hypothetically, it saves the data into database, and it mimics the success by returning true. Finally, we have the main coroutine, where we will execute these tasks, retrieving, validating, and saving data sequentially. So we are recording start time and end time as usual, and we will print at the end the total time taken by this program. Here we will call those coroutines sequentially, and to do that we just need to call each of the coroutine with the await. So first is get data, and we need to give a URL, the API URL, and this coroutine get data sends back the data from API. Secondly, we will call the validate coroutine, which takes the data that we received from API and it returns back the validated data. And finally, we have to save the validated data into database, and we need to await it. So that's all that we need to do to call the coroutines sequentially. Let's see what happens when we execute this program, and all the programs executed in a sequential order. So in sequential execution, the tasks don't start at the same time. The first one, get data, completes, then the validate coroutine starts and completes, and only then save in DB gets executed. The total time taken by this program is 1 second, which is also as expected in case of the sequential execution of these coroutines, because the get data coroutine takes 0.5 seconds, validate takes 0.2 seconds, and save function takes 0.3 seconds. So overall, it is 1 second. This might be a bit confusing for some of you. You might be thinking that as the control reaches an await statement, it should let the other coroutines continue. But it doesn't happen. This is because these three await statements are part of a single coroutine, the main coroutine. And when the control arrives, the first await, the main function gives the control back to event loop. The main coroutine pauses, and when get data completes, the main coroutine resumes. And after the resumption, the control reaches the second await. And when validate completes, the third await arrives. So this is why these statements are sequential and they don't run concurrently. And whenever we have such sequential tasks that we must perform one by one, we need to implement them this way in asyncio. Now let's take a look at the second use case. Now we have to scrap data from three websites, and we can scrap data from these websites independent of each other. This means that we don't have to follow a sequential order, and we can perform them concurrently. Now we will implement these tasks. We have created coroutines for each of the tasks. So scrap data from website 1, from website 2, and from website 3. These are similar coroutines. Again, we are simulating the operation with asyncio.sleep. In the main function, we are once again recording start and end time, and at the end we print the total time taken by this program. Here we are going to run those tasks concurrently, and to do that we have to use async.io's create task function. And this function takes a coroutine as parameter. So we pass the first one here, and it returns a task object. Let's name it task1. And we will do the same for the rest of two websites. And name tasks 2 and 3. So what is the difference between await and create task? Await, as you saw, that lets the tasks or coroutines run in a sequential order. Create tasks, on the other hand, executes the coroutine immediately, as it is called. So these three create tasks run the three coroutines concurrently. And afterwards, we can await each of these tasks to make sure that they finish. If we don't await them, and one of these coroutine takes longer than main function itself, then they might terminate abruptly. So it's important to await for their completion. Now we will run this function. Let's clear the terminal and execute it. So you see that all three tasks started at the same time concurrently, and they finished one by one. And you can see that it's not in the order of their start, it's in the order of their execution time. So if you see the code, task 2 is the smallest one. It takes 0.5 seconds. Task 3 takes 0.6 seconds. And the longest one is task 1 for website 1, 0.9 seconds. And So this is the sequence of completion. And overall time taken is equal to the longest running coroutine, 0.9 seconds, not the sum of all those coroutines. So this is a concurrent execution of tasks. So this is really good, but there is one issue I can say, that if the number of tasks increases, how do we handle that? This is not really good in this sense. So we need to do something else for that purpose. To do this in a more manageable way, let's take this code and put it in another file. So we have that same code, same task, but here we are going to make some changes. What we can do is, instead of using await, we can use single await with asyncio dot gather, and we can pass task 1, task 2, and task 3 here. So a bit more cleaner. We can still make improvement here, that we make a list of tasks. So let's take a list. All right, so we have this list of tasks, and instead of passing one by one, task 1, 2, and 3, we can pass the tasks list and expand it. So once again, let's execute this, and we have same results once again. Tasks running concurrently, and completion time 0.9 seconds. We can grow this list of tasks to as many tasks now as we want. One more thing, we can also collect the results of these tasks. So let's say this coroutine returns the data from the website 1. Similarly here, website 2, and oh sorry, this is website 3 and website 2. Now we can collect these results here as we do normally with the function calls. So maybe R1, R2, and R3. And we can also print these results here. Results. Now let's execute this function again. And now we also get the results of these websites. This implementation now looks much better and more manageable. That's all for this session. See you in the next one.